Mechan 2410 Engineering Materials Tutorial 9 Processing of Metal Alloys. We are engineers. As a result, we must know how can we fabricate and process metal and objects manufactured from metal or metallic materials. The fabrication and the processing procedures will adversely affect some of the properties of metals or metallic materials. So in this tutorial, we are going to talk about how can we fabricate and how can we process metals and how can we predict what will happen when after our processing procedures. In this tutorial, concepts from the tutorial 5 and tutorial 8 will be extensively used. Tutorial 9, Part 1, Metal Forming. Metal forming operations. Metal forming basically means that how can we practically make a material or make a metal object using some practical methods. They can be generally divided, those metal forming operations can be generally divided into two categories, hot working and cold working. Hot working implies that the permanent deformation of the material or the metals is achieved at a temperature far above the recrystallization temperature. For such kind of operations, large and repeated deformations are possible to achieve, because throughout this operation or forming process, the metal will remain soft and ductile, and the deformation energy required for hot working are less than for cold working. However, there's a disadvantages. Under such high temperature, the oxidation of that hot worked metal piece will be severe. For cold working is another type of metal forming operation. It basically stands for the deformation is achieved at a temperature below that recrystallization temperature, and it will produce an increase in strength material with a decrease in ductility. You can refer to the string hardening method in tutorial 5. It is basically when you do cold forming, you basically do the string hardening to that piece of metal at the same time. As if you permanently deform a metal, you can observe from the stress strain curve, and basically it is same as doing the string hardening. Forging. Forging is a mechanical working or deforming a single piece of a usually hot metal to a desired shape, which is a permanent deformation. And here is a picture showing how metal is forged. It basically have a container or die, which the hot piece of metal will be forged by this piece of die here and here, and it will deform to the desired shape under such influences. During forging, dislocation numbers are increased, and the metal or the alloy will experience an increase in strength and a decrease in ductility. And you can refer back to the tutorial 4 for the dislocation strengthening. Basically, more dislocations means that the deformation it will be harder to deform using the dislocation slide mechanism, and which means that the metal becomes more, it's become increased in strength. And there will be a change in grain geometry within the forged metal piece. And there is a change in grain geometry and size. Such change is anisotropic because the force cannot be in every direction. Metal forming operations, casting, and other techniques. Casting is a metal forming process in which a completely molten metal is poured into a mold cavity having the desired shape. And during such process, the metal will solidify eventually, which will have the shape. The solidified workpiece will have the shape of the mold because of that, but will experience some shrinkage in the volume. In the casting process, after the casting process, the metal piece will be isotropic in terms of the grain size and the grain shape. And such mold can be made of sand or be a dye, etc. Powder metal technology is a compression of a powdered metal, which means that you have a lot of those powdered metal and you use a very, very large force to compact them into a piece, followed by a heat treatment to strengthen such compacted metal piece and produce a denser piece, which is the final workpiece. Example: as you may know that those blacksmiths they will often forge a blade. That means use a hammer to try to make their desired blade shape instead of make a mold and cast those liquid iron into the mold and cast a blade. So here is a question raised by me: why we forge a blade instead of cast a blade? Well, this question can be explained by if we consider the nature of these two methods. In the forging process, there is a dislocation strengthening. Basically, if you hammer a workpiece, you will cause a permanent deformation within that, which basically means that it is experiencing string hardening or string hardening and dislocation hardening, both of them. And therefore, the forged blade will have an increase in strength due to the string hardening, which is caused by this hammering. But for the casting, as after casting, those residue strength within those, there will be no residue strength within a workpiece just after casting, because all those grains are newly formed after the casting process, and that's the reason the cast blade will have a lower strength compared to the forged blade, and that's why we use forging to make a strong blade.